Now, in this video, we're going to talk about how we can use the trigonometric ratios to find the measures of an angle, the acute angles, because we already know the right angle and the right triangle. So again, let's recall our little memory device, SOHCAHTOA. And let's suppose our job here was to find the measure of angle A. Well, for the values that I know here, 12 is the length of the adjacent leg, 21 is the length of the hypotenuse. So adjacent leg hypotenuse is in the ka, that's cosine. So my equation would be cosine of A, yes, it's angle A, but we'll see that in a little bit, is equal to adjacent leg divided by hypotenuse. Now, even though we could reduce that fraction, it's not going to be necessary for us to do so, because what it is we're trying to find is angle A. Now, in your notes, we talked about every operation has an inverse operation, and the trigonometric functions are no different. The inverse operation for the cosine is the inverse cosine. So if I take the inverse cosine of both sides of this equation, I'd get the measure of angle A equals the inverse cosine, that's how we write it, of 12 divided by 21. Now, some of you know that on numbers that means a reciprocal. Doesn't quite mean the same thing with a trig function. It means I'm going to reverse the cosine operation. So now this is solved for our angle. If I have a calculator that does not show me the order of operations, what I'm going to do is I'm going to put 12 divided by 21 in parentheses. Notice how I hit the left parenthesis key. Zoom in on that a little bit. And on this calculator, when I do that, the little parentheses show up in the screen. I'm going to do 12 divided by 21, hit the right parenthesis key, and now, if you notice above the cosine key is a little notation that looks like inverse cosine. It's kind of in this goldish tan, and notice that's for the second. So I'm going to hit second cosine. And if that's my last thing, it did actually then do that for the angle. So to the nearest degree, the measure of angle A would be about 55 degrees. Oops, you didn't see me write that. Now, if I'd use one of these calculators where we do see the order of operations, on this one, I would have done second cosine on this calculator. Notice it's color-coded, so inverse cosine is kind of this purplish blue. And then the parenthesis, I think, automatically comes up. We do 12 divided by 21, close the parenthesis, hit enter. Hey, about 55 degrees. Now, you want to pay attention to your directions. Sometimes they'll say to the nearest degree. Other times they'll say to the nearest tenth of a degree. Now, in this particular triangle, we're not done yet. We need to find the measure of angle B. Now, could I subtract that one from 90? Yes. You want to be careful. If we're going to the nearest degree, you're probably going to be fine. But if we're rounding to tenths or hundredths, it doesn't always work out that way. So let's suppose we just look at it in terms of the information we're using. Remember, we want to try not to have to use a rounded value to do a calculation. 55 degrees is a rounded value. So for angle B, 12 is the opposite leg, 21 is the hypotenuse. Opposite, hypotenuse, that's the sine. So the sine of B is equal to 12 divided by 21. Haven't solved that for B yet. So B, the measure of angle B, is the inverse sine of the fraction 12 divided by 21. So if I use a calculator here, this one does not follow the order of operations. So my grouping symbols here, that puts a little notation there. I have 12 divided by 21. Close that. And now I'm going to do, in this calculator, it's shift, and then the trig function, so shift for the inverse sine, and I get about 35 degrees if I go to the nearest degree. So the measure of angle B is about 35 degrees. Now, if we would have subtracted that from 90, yes, we would have come up with that. But depending upon where we're rounding, it doesn't always round to the same thing as we'd get if we subtracted. Two more quick examples here, but with the same triangle. I'm going to keep writing this out for every problem just so I have it. Once you start using it enough, you'll remember it, but it's not a bad thing to do that for now. This will be one of those things that eventually will expire. You can kind of do it for a while to remind yourself, but then after that, you don't need it anymore. So let's suppose I want to find the measure of angle J. Well, here I have the two legs. 23 is the opposite leg for angle J. 18 is the adjacent leg. Opposite adjacent, that's the tangent. So my equation would be the tangent of angle J, and I don't put the angle in when I'm writing the trig function here, is opposite leg divided by adjacent leg length. So solving for the measure of angle J, the measure of angle J would equal the inverse tangent of 23/18. Now that I've solved for the measure of angle J, I can use my calculator. I think I've used this one for a while. So turn it on. And this one does show me the order of operations. So D is up there for degrees. Shift tangent gets me the inverse tangent. So shift tangent. Notice I see inverse tangent show up. And then I'm going to have 23 divided by 18 and close that parenthesis. When I hit equals, to the nearest degree, I get about 52 degrees. So for this one, the measure of angle J is about 52 degrees. If I would have used this calculator, remember I start off with the parentheses, then do my division, 23 divided by 18, close the parentheses, now do inverse tangent, so second tangent, say about 52 degrees. Okay, we also need to find angle K. So we would know, again, opposite leg, adjacent leg, this is going to be tangent as well. But here we have 18 divided by 23. So the measure of angle K is the inverse tangent of 18 divided by 23. Now that it's solved for my variable, the measure of angle K, I can get my calculator out. So let's see here. Here's one that does not follow the order of operations, or I don't see them. It does follow them, but I don't see them all. So I have to do the 18/23 first in parentheses. So left parenthesis, 18 divided by 23, right parenthesis. Now for this one, it's shift to get the inverse tangent, and we'd have about 38 degrees. So the measure of angle K is approximately 38 degrees. Don't forget your degree symbol. On one where we do see the order of operations, so here I'm going to do inverse tangent, 18 divided by 23, see, about 38 degrees. And of course, we can find the hypotenuse by using the Pythagorean equation. All right.